Hi everyone. Today we will work through a probability example. In example 1, we are asked to find the intersection of A and B. That's this notation here, probably of A and B. And I like to start with what we're looking for, so that way I know what rules and formulas I might want to use. So far I'm looking for A and B. Now I want to look at what's given and then ultimately try to piece them together. So the first piece of information we're given is probably B complement. It's the complement by that superscript C right here. And then what I like to do is if I'm given complements, I can also find the probability of just regular B. And so that can be given by this relationship where B and B complements add up to 1. So probably B is just going to be 1 minus this 0.35, giving us 0.65. And then we're also given probability of A and probability of A or B. Now what I want to do is kind of look at what's given, what I'm asked to find, and see is there a rule or formula that might be helpful. And so I do have a rule that incorporates all of these elements called the addition rule. So the addition rule looks like this. Reads probability of A or B is going to be the sum of A and B. And then we will subtract off the intersection here. So here is my addition rule. And what I can do now is simply substitute in all of my unknown, all of my known rather, information, and then see what is unknown. So OR is 0.8, probability of A is 0.55. Now we weren't given probability of B, but above we've solved for it because we were given the complement. And so the only term that is unknown is the actual one we're looking for. And so by applying the appropriate rule, recognizing what you're given, you can often turn these probability examples into just plugging numbers into rules. And finally, if I go through a little bit of algebra and solve, we can find that the probability of A and B is going to be 0.4. Now, in the second part here, we're asked to find probability of A given B. And the given symbol is identified by this vertical bar right there. And it means given that event B already happened, well, what's the chance that A happens? Now we know the chance that A happens is over here is 0.55, but now if B occurs, then that could influence A. Again, I'm going to look at a rule that incorporates these elements. Now I do have a rule for probability of A given B. And that rule is the quotient here of A intersection B, and then divided by the probability of B. And then once again, I can simply plug in my known information. Now, both of these weren't originally given, but earlier we solved for probability of A and B. We got 0.4. And then also probability of B is just the complement of the 0.35, and we also found that was 0.65. So now, again, by simply substituting in these values, we can do our division here and get 6154. In this third example, we're looking for the probability of A and B complement. Now, this is a weird expression. There's a complement on one, not on the other one. What we can do is take advantage of a Venn diagram and kind of observe what's going on. So I'm going to draw these two events here. One of them is A, one of them is B. And what I'll do is I'll highlight the different regions that are being indicated here. So what we have is right here in this blue shaded part, well, this is just A intersection B. All right, that's where the two overlap. Now, next to that on the left here is everything in circle A, but at the same time, you'll notice it is not in circle B. So this is how we would express the orange part. Now, I do have a rule, and the rule says you can partition circle A into those two pieces that we just shaded in. So the orange piece, which is A and B complement. And then also I can add in the blue part, probability of A and B. And just like the other examples, we can now turn this into an algebra puzzle. So probably A we know is 0.55. The A and B complement is actually what we're trying to find, so that's our unknown. And then finally, we have this common term again that we've been using in all three examples, A and B. We figured out that was 0.4. And so finally, again, going through a little bit of arithmetic here, we can solve for probably A and B complement and get 0.15. And that wraps up the example 1 for probabilities.